So now let's take a look at one of the major benefits of using the derivative. As you'll recall, the derivative of a vector function will give you a vector that is tangent to the vector function. Okay, so the derivative is tangent to that curve, the path that it takes. Well, we could get a vector that's tangent to a curve, but also unit in that its magnitude is 1. Okay, so how are you going to get a vector with magnitude 1? Well, we start out with the vector r prime, which is tangent. So we got the direction down. We got a vector that's tangent to a curve. And how do we get it to be unit? Well, we just divide by its magnitude. Simple as that. So let's do an example. Here we have r of t is equal to this vector function defined for t strictly greater than 0. We can't put anything, 0 or below, thanks to this natural log. But we take the derivative, and we're pros at taking derivatives. So what's the derivative of t squared? 2t. This is going to give us a derivative with of equal to 4, and then the derivative of this is 4 over t. And then we could take the magnitude of this. Taking the magnitude means squaring each of the components and adding. And you get to this point, and you got to kind of realize that, hey, we could factor this guy, and you could factor it into this. Okay, and once you factor it into this, you could take the square root of that. So the square root and the square sort of cancel, and you're left with that magnitude. This is how long the vector function, which is the derivative, so the derivative of the vector function, how long it is. Okay, if you want to think about, and we'll talk about this more, if you want to think about this as a velocity, all right, so it is tangent to a curve, so it's kind of like the velocity, then this would be the speed, the magnitude of the velocity. And to get the unit tangent vector, well, you take r prime, divide it by the magnitude. This guy here is the magnitude. This guy here is r prime. And you're pretty much done at this stage. You could then just, for purely cosmetic reasons, do something like this, or even bring in the scalar. This here is a scalar, right? It's once you put it's a scalar function, so you could just distribute it into the derivative through scalar multiplication. So let's take a deeper look at this example. Here we have, say, the vector r of t. That's the vector function. Okay, for different t's, you get different vectors. We could then take a look at the derivative, which is always tangential to the curve. Okay, move this slightly. So this r prime then is tangential always to this curve. Okay, and that's nice, and it's also, it gets longer as t increases, as we've seen. So it's shorter here and then gets longer as you move along. But we want a unit vector in that direction, so we could divide that. We could divide r prime with its magnitude to get what's the green vector. And now notice that the green vector always has unit length as you move along this curve.